Dragons, welcome to another math task. I'm on page 8 in our notebook. We're working on beads, beads, beads. Emily has 3 bags of different types of beads. She wants to split up the beads into mixed packages to share with her friends. She wants each package to have exactly the same number of each type of bead with no beads left over. The picture shows us what amount of beads she has and what type they are. Spacers, 40 count. Round beads, 72 count. Rectangular beads, 24 count. What is the greatest number of packages that Emily can assemble? Describe the collection of beads in each package. So first you're going to attack how many packages Emily can create. But then we're going to take it to the next level, which is a bit more algebraic. Could you write an equation to represent this problem? And what would that look like? So on page 8, I've titled our new page, GCF with Distributive Property. I can use the GCF of a set of numbers in order to write equivalent expressions. There's our problem. Take a moment and attempt this on your own. When you're ready for the solution, press play again. Well, we have to ask ourselves, are we looking for multiples or are we looking for factors? Multiples, the numbers are going to grow bigger and bigger. Are we going to get more and more and more beads? Or do we need to chop up the beads? Now, we're not going to chop up a bead, one singular bead, but we are going to chop up the bag of beads, which means we're going to distribute them into packages. So 40 spacers are going to get evenly distributed, and 72 rounds are going to get evenly distributed. 24 rectangulars will get evenly distributed. So we're going to have them in all these little packages. The problem is how many packages? And how can I get the most out of it? We want the most amount of packages. Multiples or factors? If you said factors, you're on the right path. So let's take a look at it. This one's a little harder than some of the others because there's a lot of factors going on. So we're going to have to find the factors of 40, 72, and 24. Let's take a look at how we can do that. We could either do a factor rainbow or we could do a list. Let's go with a list. Okay, let's find all the factors of 40. I'm going to zoom this in for you so you can see my work a little bit better. All right, let's try these. We got 1 and 40. 1 times 40 is a factor pair. 2 and 20 is another factor pair. 4 and 10 is another factor pair. 5 and 8 is another factor pair. 6 and 7 don't work because 6 times 7 makes 42. So there, I am done. 72. There are a lot of factor pairs for 72. So be patient. 1 and 72. 2 and 36. 3 and 24, 4 and 18, 5 doesn't work, 6 and 12, 7 doesn't work, but 8 times 9 does work. And now we're back to the other side of the list. So 72 is the most complicated of the group, and 24 is the most least complicated of the group. Okay, 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 and 7 don't work, so we're done. Okay, so step 1, we found all our factors. Excellent work on that. We found all our factors. Now let's take a look at finding some of the common factors. Find out where there's a match. 1 is always a match. And this one too is a match. 4 is a match. No, 5, 6, nope. 8 is a match. 10, no. 20, no. 40, no. Okay, we're done. We found all our matches. What we found are called common factors. But for this problem, we need to know the greatest of the common factors. And that, my friends, is 8. So the GCF is 8. 8 packages. So that's where we are. We're at 8 packages. But the next step is how many of each type of bead goes inside each package. So if I have 40 beads and I have 8 packages and I want to put 40 beads into 8 packages, how many beads per package? What operation does that sound like? If you said division, you are correct. So we've got 3 types of beads. We've got some spacers, some round, and some rectangular. So we're going to take the 4 spacers, divide by 8 packages, and that's going to be 5 spacers per package. We've got 72 round divided amongst 8 packages. So we're going to get 9 round beads per package. Last, 24 rectangular divided by 8 packages is 3 rectangular per package. Great. So we found out how many packages. We found out how much of each type of bead in each package, but we haven't done anything with an equation yet. So we're going to have to move this on to the back side of page 8 in order to get an equation. Let's go there now. Let me start you off here. We have 5 spacers. We have 9 round, and we have 3 rectangular. Okay, those are all different, but they do have a number all in common. What number do they all share from the previous page? They are all in the same amount of packages. So yes, we have 40 spacers in the beginning and 72 round and 24 rectangular, but we found that they all shared the number 8. So we have 8 packages. I'm going to abbreviate packages. And inside each package, I have 5 of these, 9 of these, 3 of these. So 8 times 8 packages times all of these items. So I have 8 packages of 5 plus 8 packages with the dot is multiplication, 9. And I have 8 packages with 3. So I have 40. 8 times 5 is 40. Plus 8 times 9 is 72. Plus 8 times 3 is 24. I hope those numbers seem familiar. You saw those numbers on the other page. 40, 72, 24. So we must be doing something right. 8 packages of 5, 8 packages of 9, 8 packages with 3. Or 8 packets with 5, 9, and 3. Well, I'm going to show you something neat. I'm going to take the words out of here. I'm just going to do numbers and symbols right now. When you press parentheses right up next to a number, it means to multiply. So you're going to see me do that right now. 8 times 5 plus 9 plus 3. Eight has to multiply by everything inside those parentheses. Next, that is the same value as 8 times 5 plus 8 times 9 plus 8 times 3. What's even cooler is 8 times 5 plus 8 times 9 plus 8 times 3 is the same as 40 plus 72 plus 24. And I can play with these numbers even more. I have an equation here, an expression equal to another expression. I have an equation here, an expression equal to another expression. I could even do, well, let's try this. What is 5 plus 9 plus 3? 17. What is 8 times 17? Let's work it out over to the side. Did you get 146? Should be 136. I double checked it. 8 times 7 is 56. Put down the 6. Carry the 5. 8 times 1 is 8. 9, 10, 11, 12, 13. 136. Okay. So 136. Let's see if any of these other things come out to be 136. If we're going to say this is equal to this and all those things are equal to each other, add these three up. See what you get. Oh, that's nice. So I just proved that this is equal to this is equal to this, and this is equal to this. That is how you use the greatest common factor in an equation. But where's the greatest common factor hiding? It might surprise you. He's kind of hiding outside of the parentheses on that expression. But then he's inside all of these parentheses because he has to visit each type of bead. Each bead is inside each package. Each type of bead is inside each package. So this is just an overview of how to do this, and we're going to go into more of these notes tomorrow. But hopefully you're starting to see how all of the numbers work together. So thank you for joining me, Dragons, and have a good evening.